So your x-intercepts, you can find those using your graphing calculator by using the analyze graph, and you go into and you find the intercepts or zeros. These are your x-intercepts. That's the answer to number 1. Okay. How would we find out how many eggs were observed at the beginning of the study? So how can we find that number? You could either find the y-intercept, or you can go to your data and take that number. Either one would have been intercepted. So 10,400 or 534 is how many eggs you began with.
Where's question 2?
It's after question 1.
A, B, C, D, E, F.
So if we want to take and figure out when is my graph increasing, I want you to circle on your graph where you think the graph is increasing, from where to where. So we're increasing as we leave this point, the 5.748, until we get to the 21.5. So if I was to write that out, by interval notation, you use the x's to identify it. So that's that 5.748, and then you put a comma, and it stops at 21.5. And I used parentheses because at these points here, the maximums and minimums, I'm neither increasing or decreasing. So you use a parenthesis to represent that, because that means we're getting really close to that point, but not being exactly. Is that the only point in which my graph is increasing? It's also increasing this last section. So that means if I start at the x, that's going to be 38.2. And I'm going to go until, what's my furthest to the right I'm going to stop at? You're not. So what do we use in that place?
Mm-hmm.
So let's now look at, and you can either square the sections that are decreasing, or if you just want to have them not marked so it stands out, we're going to go back and look at our decreasing sections. So how many decreasing sections do I have? I have this section and that section, right? So what is the farthest to the left I will end up being?
Infinite.
And it's going to be negative infinity because it's to the left. Where does it stop? Here.
4.
No, that's the x-intercept. We're going to stop at the low point.
5.7.
And then where else am I decreasing from what 2 points? So what is my x value here? 21.5. What is my x value here? And again, I use parentheses. So relative maxes or relative mins are any point that has a high point or low point on the graph. It's not the absolute highest point or the absolute lowest point, but it's like a turning point. Is there any valleys or hills? And so, is there any valleys or hills? Let's look for the valleys. We have two valleys. So our two relative mins are that 5.78 or 748, negative 311.5, and that 38.2, comma, negative 2,807.2. Our relative max is any mountaintops. And so our mountaintop, the only point we have that is a high point is going to be this one. And so we have that point. The difference between relative mins and maxes is any point that it's at the high or low on a relative. Absolute maxes are mins. So when it says that word absolute, that means the highest, the maximum, the minimum. Meaning there is no point on the graph lower or higher than that. Is there any point on the graph that you would call that? Is there any point that has the absolute highest point? No, because these graphs are going to continue going on forever. So there is no absolute max, as there is no spot that is the highest. Is there any spot that is the lowest? So we have two low points. Is one of them lower than the other? So this point here is the lowest the graph goes. So therefore it is the absolute min. So that's our absolute min. So absolute min is different than relative min, and the fact that it is the lowest point on the graph. There is no point lower than that. This is the reason I had y'all last week play around a little bit on the Mathia, working on finding the absolute mins and maxes, because we're going to be using that information to help us graph. So that Mathia we did last week was kind of building towards this topic. So Let's just say 1, 0. A linear graph is a straight line. It will have one point where it crosses the x-axis. So it has 1, 0. A quadratic function is a parabola. It can have up to 2 times it crosses the x-axis. The cubic function can have up to 3 times it crosses the x-axis. I want y'all to look and see what is the same and what is different about these different types of graphs. So you said something about that they all have a maximum or a minimum. The similarities are that you said that they have.
If it has more than 1 0, it will have a distinguishable maximum or minimum.
Has more than 1 0, it's going to have a distinguishable maximum or minimum. What else is there?
Are we talking about similarities or difference? Or both?
Both.
I could draw a pretty good linear graph compared to the cube one.
So the maximum number of distinct zeros. What's the maximum number on a linear?
0.
1.
Oh, why
What's the maximum number on a quadratic?
2.
Cubic.
3.
So what's the degree of a linear?
1.
What's the degree of a quadratic? What's the degree of a cubic? 3. So the maximum number of zeros is going to match the degree of the function. The total number of real roots minus any multiplicities represents the number of x-intercepts. Guys. And
Yeah, you're in trouble.
okay. The only graph that can have a possible not crossing the x-axis is which one?
Quadratic.
Quadratic is the only graph that doesn't have to cross the x-axis. There's a difference. So is there any other questions that y'all have for me on those?
Mm-hmm.
Are those the only ways I can draw those?
No. You draw them sideways.
Okay, so let's look at it. I want y'all to do, y'all are going to take and graph each of these with a different way. With 1 0 for a linear. 2 distinct zeros, I want you to graph it a different graph for a quadratic. So like for linear, another graph I could have drawn is one that slants this way. So there's other graphs that can fit these number of zeros, but that doesn't have to match. So when we had 2 distinct zeros for a quadratic, you just had to draw a parabola. It crosses the x-axis twice. It could have opened up. If it opens up, it has an a bigger than 1, or bigger than 0, so positive a. So if it has 1 real 0, that means it just touches the x-axis somewhere. and goes away. So I could have drawn it going upside down. I could have gone up from there. I didn't have to. For 2 imaginary, it just can't go through the x-axis. For a cubic function with 3 distinct zeros, that means I go through the x-axis 3 times. So something like that. So on a quadratic, both sides go the same direction, correct? What about on a cubic? Do both sides go the same direction? No, they go opposite. The A value determines which way the right-hand side goes. So if A is negative, and this one is when the A is positive. So a real zero with a one real one with a multiplicity of 3 can be drawn something like this. That's an example of one real with a multiplicity of 3. So if you have 1 real and 2 imaginary, or excuse me, 1 real and 2 with the multiplicity, I forgot which one was next. This means we touch one place and go through another. And so the one I drew had an A that was negative, the one that was there had an A that was positive. If I want to draw a real and an imaginary and 2 imaginary, oops, that was not what I intended. There we go. There's 1 real and 2 imaginary. So you could have graphed something completely different than mine. As long as it fit those kind of criteria, it works. So we are going to take information. We're going to take different characteristics and we're going to come up with a graph. This graph is not always possible. So if you find one that's not possible out of these, there is going to be one that's not possible. We're going to take each of the characteristics and you're going to draw a graph. So if it says a degree of 3, what does that mean it is? Has an A value of less than 0. So that means that the left side will be going up because the right side has to go down. And at x equals 3, it has a relative maximum. Does it tell me how high it needs to be? So you choose a point at x equals 3 that you want to be your highest point. I'm choosing this point. So we know that the right-hand side has to go down, right? So I'm going to draw my right-hand side going down. What other things do I know? If this is my highest point, what do I need to do when I leave here? Go down. Does it tell me how far I have to go down? No. So at any point here, I can go back, start curving back up. Y'all are going to do the same thing for B, C, and D. Choose which graph makes sense, linear, quadratic, or cubic, and then sketch the graph. So what type of graph is B? What do you think?
Linear.
You could do a linear. And so if you did linear, it's the most straightforward. You would take and go, okay, at 5, I'm going through the y-intercept, and your graph will look something like this. Is that the only way you could have drawn this graph?
No. Yes.
Okay. You could have also drawn it as a cubic. Oops, I did draw it going to that point. Where it curves in and comes out like this. And those are with one distinct zero here with a multiplicity of 3. That's another way you could have drawn it. Three x-intercepts. Does it tell me where those are? So what type of graph is this? Cubic, okay. So I'm just going to go ahead and draw in 3 x-intercepts. What other information does it tell me?
Relative maximum is at one.
So I know on this line here is the highest I can go on one spot. I can cross through it, but there's going to be one that has a spot there it touches. Okay? A value is greater than 0. So what does that tell me? Which side's going to go up? Right or left? The right is going to have a tail like this and like this. So right will be up because it's positive, and left will go down. So if the right's going up, just go ahead and sketch it that way. From here to this point, we're going to have a low point, right? So sketch it between there. Between these 2 points, I need to have a high point. Well, that high point needs to be at that 3. And there's you a sketch of a graph. Depending on where you put your zeros, it could look different. Depending on how low you put your relative min, it could look different. And D, I have x-intercepts. It tells me where they are this time. Has a negative a value, so that means that my right-hand side is going down. But my degree is 2. So which graph has a degree of 2? Quadratic. Is there any way a parabola can go through the x-axis 3 times? No. So it's not possible. Y'all are going to do the talk for homework.
Yes, ma'am.